Hello everyone, I am Divya Bharati and my teammate name is Shagita Banu. We did an internship on embedded system at Emertxe Technologies. So here I am going to explain about microwave oven simulation which I was learned during this internship. Let's get into the project presentation. The table of contents are: what is microwave oven, what are the requirements, what is embedded system, what are the types of embedded system, what is microcontroller and microprocessor, peripherals in microcontroller, and finally we will see the demo of this project. What is microwave oven? Microwave oven is used to heat the food using microwaves, which is of form electromagnetic waves. Types of cooking modes: micro mode, grill mode, convection mode, start mode. Micro mode. In this mode is used to cook food in a traditional way. It uses a maximum power of 900 watts. In this, the maximum time that you set for cooking is 60 minutes. Grill mode. This mode is used to cook meat and bread. It works as the micro mode, but the purpose is to cook meat and bread. User can set time as per the cooking time of the meat. Convection mode. In this mode, user can set the oven to preheat for a particular temperature, and it takes 3 minutes to preheat the oven. After preheating is done, then the user can set the time as per the requirements. Start mode. It will start the oven by default 30 seconds. If you want to add the timing, press the start key again and again. Requirements: knowledge in Embedded C, MPLAB XID, X8 compiler, PIXSIMLab, PIC16F877E microcontroller, 16x4 CLCD, matrix keypad, tactile switch, and timer. What is embedded system? Embedded systems are computing systems with a tightly coupled hardware and software integration which are designed to perform a dedicated function. Examples: network router, refrigerator, etc. What are the types of embedded system? Real-time embedded system, standalone system, network system, mobile system. Standalone system is furtherly divided into two categories. One is a slave system and another one is independent system. A real-time system. If the system is capable of taking action in a given instance of time. There are three types in it: hard real-time system, soft real-time system, and firm real-time system. Hard real-time system. The application may be considered to have failed if it does not complete its function within an allotted time span. Example: fire alarm, pacemaker. Soft real-time system. It is a system whose operation is degraded if the results are not produced according to the specified timing requirement. Example: DVD player, television. Firm real-time system. The system is one in which a few missed deadlines will not lead to total failure, but missing more than a few may lead to complete or catastrophic system failure. Example: moon rover. Standalone system. First one is slave system. These systems are not intelligent even though these are embedded systems. These systems cannot take action by their own. Example: semi-automatic washing machine. Independent system. These systems can take action by their own. Example: Google cars. Network system. The systems which are connected to the network is called as network system. Example: home security system. Mobile system. The system which are movable are called as mobile system. Example: robots. Microcontroller. Microcontroller is a small computer on a single metal oxide semiconductor integrated circuit chip. It contains one or more CPUs along with memory and programmable input-output peripherals. What is microprocessor? The microprocessor is an electronic component that is used by a computer to do its work. It is a central processing unit on a single integrated chip containing millions of very small components, including transistor, resistors, and diodes that works together. Microcontroller versus microprocessor. In microcontroller, all the components will be in a single chip. But in microprocessor, all the components are assembled separately. Microcontroller has less flexibility and less design complexity. But microprocessor is more flexible and more design complexity. Peripherals in microcontroller: CLCD, matrix keypad, tactile switch, LED, timer, interrupt, ISR, and then buzzer. We will see one by one. CLCD. CLCD stands for Character Liquid Crystal Display. In the Pixim lab, there are two types of display. One is 16x2 display and another one is 16x4 display. It displays the ASCII character and some special characteristics. It is the most commonly used display. There are two types of communication modes. One is 4-bit mode, another one is 8-bit mode. Matrix keypad. This is a keypad in which a number of tactile switches are connected in a row and column concept. It is a small, compact device that accepts the user inputs and processed by the microcontroller. These are commonly used in devices like calculator, digital locks, gas pumps, and eye projects, etc. Tactile switch. Tactile switch is a switch whose operation is perceptible by touch. The click response of the button lets the user feel the response of the operation from the switch. This switch will produce a bouncing effect when it is pressed. There are two types of circuit. One is pull-up resistor circuit, another one is pull-down resistor circuit in the tactile switch. LED. LED stands for light emitting diode. It is a semiconductor source that emits light when current flows through it. Timer. Timer is a software used to count the time interval between the events. Resolution, which is also called as the register width. Interrupt. Interrupts are the events that temporarily suspend the main program, pass the control to the external source, and execute their task. Then it passes the control to the main program where it had left off. Classifications of interrupt. There are two types of interrupt. One is hardware interrupt, another one is software interrupt. In the hardware interrupt, hardware interrupts are further divided into maskable interrupt and non-maskable interrupt. ISR. ISR stands for Interrupt Service Routine. Whenever an interrupt occurs, the controller completes the execution of the current instruction and starts the execution of an interrupt service routine. It tells the processor or the controller what to do and when the interrupt occurs. Buzzer. Buzzer is a sounding device that converts the audio signals into the sound signals. It is widely used to notify various events such as interrupt generation, end of any process, or as an alarming on emergency situation. Let's get into the simulation part of this project. So let me open the MP Lab XID. This is the interface of the MP Lab XID, and here you need to write the program for this project. In the header file sections, you need to include the .h files like this, and in the source file sections, you need to include the .c files like this. We are already completed the coding part for this project, so now I'm going to build this. Here you can able to see the build is going on, so we will wait for few seconds. Here you can able to see the build is successful. So now I'm going to load this file in Pixim Lab. Let me open the Pixim Lab. This is the Pixim Lab interface, and let me load this file. File load hex. Okay. Now I select this and I'm going to open this. This is the powering on screen, and after a few seconds it will display the cooking modes like this. We will see each mode separately. That means one by one we will see. First one is micro mode. If you press key number 1, micro mode will start. Micro mode started. Here you need to enter some timing to cook the food. I enter some timing, 32 seconds, 5 minutes. If I need to clear this timing, press the start key. If I again press this, it will clear the seconds also. Okay. Now again I enter some timing, 56 seconds, 2 minutes. If you want to confirm this timing, you need to press the hash key. Now I confirm this by pressing the hash key. Okay. Here you can able to see the process is going on. The fan is also running. Okay. In between this process, if I want to stop this process, if I want to pause this process, press the key number 5. Here you can able to see the process is paused. If I want to restart again, press the key number 4. The process again started. Okay. And one more thing, in between the process, if you want to check whether the food is cooked or not, you need to open the door of the oven, right? So here we are using RB3 key as the door open key. So if I press this key, it will indicate like this. That is, the door is in open condition, so please close the door. Okay. And now I'm going to stop this process by pressing the key number 6. If I press the key number 6, it will again get back into the cooking modes. We will see. Now I press key number 6. It will again get back into the cooking modes. Okay. Next we will see the grill mode. To start the grill mode, we need to press the key number 2. Here you need to enter the timings to cook the food. It is also similar to the micro mode. Now I enter some timing. Let me confirm this by pressing the hash key. Here the same process which I was seeing in the previous mode. Okay. I think there is no need to explain furtherly. So I will stop this process by pressing the key number 6. Next mode. We will see the next mode. Next mode is convection mode. To start the convection mode, press the key number 3. Okay. In this, you need to enter the temperature to cook the food. Now I enter some temperature, 53 degrees Celsius. Now I confirm this. After entering some temperature, it will preheat the oven by default 180 seconds, that is 3 minutes. So we will wait for 3 minutes. The oven is in preheating, so we need to wait for a few more seconds. Wait for a few more seconds. Just 60 seconds is there, so we will wait. Five, 3, 2, 1. Okay. Preheating is done. Now we need to set the timing to cook the food. Now I set the timing like 32 seconds and 9 minutes. Now I confirm this by pressing the hash key. Now the convection mode started. It is also similar to the previous mode what we seen, right? Okay. If I stop this, if I want to stop this, press the key number 6. Okay. It will again get back into the cooking modes, and we finish the cooking convection mode also. Then finally we will see the start mode. To use the start mode, press the key number 4. It will start the oven by default 30 seconds. If you want to add the timings, press the key number 4 again. If I press this, it will add 30 seconds to the previous timing. If I again press this, it will again add like this. If I want to pause this process, press key number 5. If I want to restart again, press key number 4. And okay, now I'm going to stop this process. Okay, finally we completed the simulation part of this project. So thank you.